Okay, so in this challenge we have to add a node to a binary tree. So binary tree it's a data structure, and it's like an inverted tree that you would see in nature. So this is called the root, and the root is going to be the topmost node, which is, first it's going to start off as null. That's if it's empty. But otherwise, everything to the left of each node in a binary tree, everything that's to the left is going to be less than, and everything that's to the right is going to be greater than itself. So we see 8 is the root, to the left is 3, and to the right is 10. Now these pointers over here, they're called edges, and if a node has no children, then it's called a leaf node, and it can have no children, or it can have at most 2 children. Right? So if you think of a node as an object, it's going to have a value property. Right? In this case, it's 8 for the root. This one is 3. And it's going to have a left prop, and it's going to have a right prop. All right, cool. So let's do this. And over here at the top, we have a little helper function to help us console.log it. First thing we're going to do is we're going to let's use this constructor. Let my tree equals new binary search tree. I'm going to point to this to my tree. Okay. And then we're going to do, so we're going to call display tree. We're going to pass in my tree. I have a root of null. Very cool. It's exactly what you would expect, right? So what we're going to have to say is, the first thing we want to do is we're going to add a node to be the head node, right? So we want to add, let's add an 8. If this dot root equals strictly equal to null, right? So what we're going to do is we're going to say this dot roots equals, right? We're going to use this constructor, right? This node constructor. We're going to pass in the element. I'm sorry. We need to add this method to it. We're going to just take this and paste that in it. Let's tab it out a little bit. Okay, cool. So now we're gonna do let's add 8. All right, so we got a value of 8, we got a left of null and a right of null. Right, so now we need to go to. So now if the root isn't null, it means we have one. So we're going to do this, right, else. So the root's not null, right? So first thing is we need a pointer to point to the root. At the end I'll explain to you why we need this pointer. So let's call it head. This dot root. Right? So what I want to do is what I want to say here, if, right? Well, first of all, let's do the right side of the binary tree, right? So remember, everything, if it's greater, it's going to go to the right, right? So if element is greater than head dot value, right? So we said we have a value. What do we want to do? It's the value property of that object. Then we have to check two things. Well, first of all, it might not just be by itself, like this node by itself. It might have a child. So first of all, let's pretend it's just the root by itself. So we have to say if head dot right, if it's strictly equal to null, right, it doesn't have any right children, then we can just stick it there, right? So we can say head dot right equals equals this, and we're going to use this constructor, and we're going to pass in the elements. Right? All right. And for here, we're just going to console.log. It is not. It has a child. It has a right prop. Let's just say that it has a right prop. Okay. So, right. So let's add 10 according to this diagram. So we're going to do mytree.add. Add 10. And then let's add the 14. So it has the right prop, right? Okay, so what we want to do is we want to make this right prop. We want to basically advance, right? So we want to set this right prop. What we want to do is we want to say let head equals to head dot right. Cannot read property right of undefined. Okay, so basically, yeah, so the head, right, let me actually just put it this way. Head before, right, so this is the head before, it's 8, right? If we've added 14, and then let's see what the head looks like after. The head afterward is going to be the right property of what it was. So the head after, if I do it afterward, it should be this one. This should be the head. And say head after. Yeah, so you see it's how it's the right property. It's the head. This one over here, so you guys can see it. Okay, right. So you see how this is it. This is the one afterwards. But I need to I need to kind of do this again and again and again, over and over and over in a circular fashion. So right away, you guys should think of recursion. So I need to find something that calls itself, right, in this case, because I need to have a way to keep doing this process more than once if I want to keep adding over and over and over. So let me create a function, right? Let's call it search add. It's going to get an element. Take all this over here. We're going to cut it. We're going to paste it. Right, and then right over here, I'm going to call itself. Let's call search add right over here. We're going to wait 1 second though. Let's not do anything right now. Okay. So right over here, I have to, what I'm going to do is I'm going to call search add. Well, this actually isn't a good name for a variable. This head isn't a good name. I'm going to call it currents. That's a better name. Right, because it's the current one that we're looking at, and it's going to change, right, depending on each time you add one, it's going to advance. The current one is going to be, it's going to be like you're passing in a new root into this search add function, and each time, like, the first time it was 8, and the second time it's going to be 10. I'm sorry, the first time is not 8 because 8 would be up here. 8 is added over here in this case of this block, but right after you add 8 over here, right? So the second time, right? I'm sorry, it would only be called the third time, right? Then you would call it actually over here. Well, it is called the second time because it's going to be called into this else at the bottom, right? So the second time you add a node for the second node, it is going to be called, and then the third time, it's going to be the third time. It's actually going to be called twice because I'm going to call it here, and then I'm going to call it inside of itself. You'll see what I'm talking about. So then I'm going to call again. So I'm going to call search add current. Very cool. All right, so it added it 14. Now let me add another one. Let me add no, 14. That's not good. I didn't do the left side yet. I'm gonna do 15. Yeah. So you see how it's working, right? It's giving me a right value 15, a left of null, and a right of null, right? So now what I'm going to do is I'm going to add right now. Now we have to do the left side, right? Because we've already done the right side. This will take care of anything that's greater. Any node that's greater than its previous, than its parent, right? I'm sorry. Okay, so now we have this. So now we need to do the same thing, right? So if I'm not going to say else, just because I don't want to say else, because if I use else over here, then it's not going to take care of a case where it's equal, and I don't want to do anything with the same node, right? If it's already if we already put the node in before, like it's the same value, then we're not gonna do anything in that case. So that's why I'm not gonna do the else. If current dot left, element is less than current dot left, current dot value. If element is less than the current dot value, right? So then we're going to say the same thing. If current dot left, if it's empty, if there's nothing there already, so we're just going to put it in. Equals new node elements, right? Otherwise, else the current equals current dot left, and then we're going to search add current. Okay, so let me add 3. Get rid of this 15 over here. Let's add 3. There we go, left 3. And this left, which is 3, doesn't have anything because we didn't add it. Let's check it. This should, I think, will work. There we go. Boom. Okay. Now I wanted to explain to you why I need this pointer over here, because initially I also was confused, right? So for this, I'm going to actually not use this console. Use this console. Let's clear this. And I'm going to not do any, let's just use the right to simplify this argument. So nothing that is less than. Let's get rid of this for now. Just for now. So let's make this, let's leave this alone, right? So let's actually take this dot root, you're going to see what's going to happen, why it's not going to work exactly as what we would want. Okay, so you see how it's always overwriting itself? Right, let me actually just do 1, 2, 3, so it'll be clear. 1, and you're going to get 2 and 3. Two and 3, right? So why does it happen, right? The reason it's happening, right, that it's overwriting itself, is because of this line over here. Right, it's always setting the root to what the write's root was, right? So because if we watch over here, let's console.log this dot root, right? So this was the root before, and if we do this, root after. Right, okay, so you guys see how this was, the root before was 1 with the left of null and had the right of this node, which was going to be the object with value property of 2, right? So now, right, the root after is this, right, which was the right before it. So the before, so what was before came, we switched it out for what was afterwards, right? So that's why it overwrote itself over here. Right, because now this became the roots. Right, that's why you need the pointer, and that's why it only works with that pointer variable. All right, so I hope that's clear. If you guys have any questions, feel free to ask in the comments, and I hope this clarifies to you how to add a node to a binary tree.